Here is the data set that we will use for our example correlation analysis. Notice that we have the name of each participant and we have two variables for each participant. We have their homework score and their GPA. So the pretest for running a correlation analysis involves checking the data for three items: for normality, linearity, and homoscedasticity. And so the two variables involved in this correlation analysis, our homework variable and GPA, they both need to be inspected for normality. And so to do this, we can generate histograms with normal curves for homework and GPA. So we can complete the following steps to produce a GPA with a normal curve for homework and GPA. So we are on our main screen here, so we can click Analyze, Descriptive Statistics, and Frequencies. This will take us to the Frequencies menu. And so on this menu, we want to move homework and GPA from the left window to the right window. And with this data in this configuration, you can order both histograms at the same time. So we want to click on our charts button. It will take us to the charts menu. Click on histograms. And we also want to show the normal curve on the histogram. We want to check this checkbox. We'll click continue. It will return us to the frequencies menu. Click on OK, and the system will produce two histograms with normal curves for homework and GPA. So we can check our statistics here. Notice our N is 30 for homework and GPA, so we know that we've included all our entire data set. We scroll down here. If you look, the curves on each histogram, so here's our first one for homework and our second one for GPA. They are reasonably symmetrical, bell-shaped. They're not perfect by any means, but there's no notable skewing, and hence these criteria are satisfied. I would say that if it's not extreme, the test for normality is usually it usually passes. So linearity and homoscedasticity are both graphical in nature, and they are actually read off of the scatter plot with the regression line. And so we will observe and discuss the findings for these two remaining criteria in the results section. So to test for correlation, it's a two-part process. So first, we will process the correlation table, which will render the correlation value R and the corresponding p-value. Next, we will order a scatter plot, which will provide a clear graph showing the paired points from both variables plotted on an X and Y axis, along with the regression line, sometimes referred to as a trend line, which can be thought of as the average pathway through the points. So let's go back to our data set here. So we want to go back to Analyze. This time we're going to click on Correlate by Variate, and this is going to take us to the Correlate menu. So on the Correlate menu, move homework and GPA from the left to the right window. We will click on OK, and the correlation will process. So here's our correlation table, but for now, let's set aside the correlation table that's produced, and we will interpret it in the results section. We're going to go ahead and order a scatter plot with a regression line. So let's click on Graphs, Chart Builder. We'll just click on OK here. All right, this is, so now we're in the chart builder. So we want to choose scatter plot, and we're going to choose the first choice, so we can just move that on right here, just drag it. We are going to then move homework to the x-axis, and drag GPA to the y-axis and then click OK. So now that we've produced a scatter plot, we also need to order the regression line. So in this output window, I can double click my scatter plot, and this will bring us to a chart editor. And there is a little option here called Add Line Fit at Total. And so we want to click that icon so it can include a regression line on the scatter plot. So once we see this regression line emerge in the scatter plot, we can just go ahead and close this chart editor, and you'll see the regression line is now included in the output window. So we can go ahead and close that. We have our regression line here. So now we want to, we're going to start discussing the two elements present in this scatter plot, the point and the regression line. So now we're going to finalize the two remaining assumptions, our pretest criteria, linearity and homoscedasticity. And finally, we'll discuss the overall meaning of the scatter plot and the correlation findings. So the simplest way to conceive the regression line without presenting the formula or without going into a great deep discussion about the formula is to think of it as the average straight line pathway through the cloud of points based on their positions. So just as the descriptive statistics provide a summary of a single variable, the regression line provides a short graphical summary of two variables, in this case homework and GPA. So we've already covered the first assumption, normality of distribution of the two variables, homework and GPA, via the histograms with normal curves. Now we want to assess the remaining pretest checklist criteria, or the two remaining assumptions, linearity and homoscedasticity. So first, let's look at linearity. The points on the scatter plot should form a relatively straight line. The regression line should take a middle of the road path through the cloud of points. If the overall shape of the points departs into some other shape that is not conducive to drawing a straight or regression line through, then it would constitute a violation of the linearity assumption. So it does follow through the points fairly clearly, and I would say that we have met the assumption of linearity. So next is homoscedasticity. So this pertains to the density of the points along the regression line. So with this assumption is satisfied when the cloud of points is densest in the middle and then tapers off at the end. So the rationale for this distribution, so it should be the densest in the middle, tapers off at the ends, and notice this kind of reminds you similar to a histogram. Okay, so where the majority of the values are gathered around the mean. So this data set has also met the assumption of homoscedasticity. So now let's go back to the correlation table and let's examine the results, and let's interpret the results here. So this shows a positive correlation of 0.881 between homework and GPA with a p-value of 0.000. So there's actually no such thing as a p-value that equals 0. So in this case, it's just extremely, extremely small. So we could say that this p-value is less than 0.001, for instance. So when it's less than 0.01, it's typically noted as p is less than 0.001. So since the p-value is less than the alpha value of 0.05, we would say that there is a statistically significant correlation between homework and GPA. The positive correlation, R equals 0.881, pertains to the positive slope of that regression line. So we have a positive strong correlation, Okay, a strong positive correlation between these two variables, and also a significant correlation between these two. And so when you are writing up your results, if you are writing these up in an abstract, because this is what you're going to be doing for homework, so in about approximately 200 words, how could you describe briefly what the study is about and your findings, your results? So for this particular example, we could say we were interested in discovering if there was a correlation between the number of hours of homework a student did in a week and his or her GPA for that week. Correlation analysis revealed a strong positive correlation between these two variables, R equals 0.881, which was statistically significant. P was less than 0.001, using an alpha value of 0.05. As such, we would reject HO and H2, but not reject H1. So this was a discussion of a correlation analysis. We went through a sample correlation and how to write up your results. I hope you have a pretty clear understanding of this type of analysis, and you'll be doing a similar analysis in your homework. You guys have a great week. Thank you so much.